Good morning, everyone. Now we have section 10.7, complex numbers. Now we know that any negative number inside the square root, like this, square root of -1, this is not real number. So it is not defined in real numbers. But in complex number, this is defined. So we will let square root of -1 equal I. I is imaginary unit. So we will let the imaginary unit I represent square root of -1. So now it is defined in the complex number. So if square root of -1 equal I, then to simplify this, square root of -4, we can rewrite this by the properties of radicals. This is equal to the product of two radicals, square root of 4 times square root of -1. Square root of 4 equal 2, and square root of -1 equal I, which is imaginary unit. So now square root of -4, which is not real number, is equal to 2i, which is a complex number. Another example. If we have square root -25/49. So this radical is equal to the product of these two radicals by the properties of radicals. By the properties of the product of two radicals. So square root of 25/49 equal 5/7. So square root of 25 is 5. Square root of 49 is 7. And square root of -1 equal I. So equal 5/7i. I square. So we know that I is equal to the square root of -1. So quantity square. So if we multiply this radical by itself, we get -1. A complex number is any number of the form a plus bi, where a and b are real numbers and I equal square root of -1. A is called A is called the real part of the complex number, and B is called the imaginary part of the complex number. Now two complex numbers are equal, so if we have two complex numbers, the first one is a plus bi, the second one is c plus di. So these two complex numbers are equal if and only if the real part is equal, so a equals c, and the imaginary part is also equal, which is b equal d. So if a equals c and b equal d, then we say that these two complex numbers are equal. Now, the complex number a plus bi is a real number if b is equal to 0. So if b equals 0, so 0 times I is 0, so we get a is a real number. Now a plus bi is an imaginary number if a is equal to 0. So if we substitute 0 for a, so we get bi, so bi is complex number. Now the conjugate of a plus bi is a minus bi. Arithmetic of complex numbers. So we can add or subtract or multiply two complex numbers or divide two complex numbers. The result is also a complex number. So to add two complex numbers, so here for example we have a plus bi, this is a complex number. C plus di is another complex number. So to add these two, just first remove the parentheses. So we get a plus bi plus c plus di. Then bi reorder, so bi plus c, we can rewrite it like c plus bi. Then a plus c together, this is real part. Then bi plus di, factor out I, so we get b plus d times I, which is also a complex number. So here the real part is a plus c, the imaginary part is b plus d. Similarly for subtraction, if we subtract two complex numbers, so the first one is a plus bi, the second one is c plus di. So if we subtract, so first remove the parentheses, so we get a plus bi. So negative means negative 1. Negative 1 times c is negative c. Negative 1 times di is negative di. So also reorder. So we get a minus c plus bi minus di. So bi minus c, we can rewrite it like negative c plus bi by commutative property. Then combine like terms. So a minus c is a real part, plus factor out I between these two terms, factor out I, so we get b minus d times I, which is also a complex number. So the real part here is a minus c, the imaginary part is b minus d. To multiply two complex numbers, so the first one is a plus bi times the second one, which is c plus di. So here to multiply two complex numbers, use the FOIL method. So the first product, a times c, is ac. A times di, a di. bc times c, bci. Then bi times di, bd, I square. So I times I is I square. Now we know that I square equal what? I square, if I equal square root of negative 1, I square is negative 1 or square root of negative 1 square, which is equal to negative 1. So substitute negative 1 for I square. So negative 1 times bd, so negative bd. Then keep the ac and adi plus bci. So now combine like terms. So here ac with negative bd are real numbers. So ac minus bd together. Then these two also together. These two are complex numbers or imaginary part. Factor out I. So equal AD plus BC times I. So now the result is also a complex number. The real part is AC minus BD. The imaginary part is AD plus BC. Multiply. So here we have excuse me, we have 2i, which is a complex number. So here the real part for this complex number is 0, so we can write it like 0 plus 2i, or just 2i. So 2i times 7 plus 2i, so here use distributive property. So 2i times 7 is 14i. 2i times 2i, 4i squared. But I squared is negative 1, so 4 times negative 1 is negative 4. Then here we have 14i. Always in the complex number we write the real part first, then imaginary part second. So negative 4 first, then 14i. Multiply these two complex numbers. 5 plus square root or square root of 3 times I times 2 minus square root of 3i. So use the FOIL method. So 5 times 2 equal 10. 5 times negative square root of 3i equal negative 5 square root of 3i. Now inner product. Root of 3i times 2 equal 2 root of 3i. Then root of 3i times negative root of 3i. So first positive times negative is negative. Root of 3 times root of 3 is root 9, and root 9 is 3. I times I is I squared. Now simplify. These two terms are like radicals. Why? Because we have same index, square root, square root. Radicand is a 3, radicand is a 3. So we can add. So to add, just add their coefficient. So here we have minus 5 plus 2 equal negative 3. Then keep the radical and it is radicand the same. So equal negative 3 square root 3i. The last term, negative 3, I square equal negative 1. So negative 3 times negative 1 is positive 3. So 3 times 10, these two terms are like, equal 13. So 13 minus 3 square root of 3i, which is a complex number. Write as an imaginary number in the form bi. So here write this radical in this form, bi. So here use the properties of the product of two radicals. So here, this radical is the product of these two. Square root of 16 is 4. Square root of negative 1 is I. So this is equal to 4i. So now 4i is in the form like this, bi. So here b is 4. Similarly, this one, square root of negative 81. So negative 81 is 81 times negative 1. Square root of 81 is 9. Square root of negative 1 is I. Square root of negative 11. This one is the product of these two radicals. So 11 here is not perfect square, so we keep it. Square root of negative 1 is I. So the answer is root 11 times I. Now power of I. We know that I equals square root of negative 1. This is one imaginary unit. So if I need I square, so I square is, so I equals square root of negative 1. Quantity square, so multiply this radical by itself, so we get negative 1. So now if I need to find I cube is I square times I. But I square is negative 1. I square is negative 1 from this property. I square is negative 1. So negative 1 times I equal negative I. So now I cube is negative I. I square is negative 1. And I is square root of negative 1. If I need I to the power 4, so I to the power 4 is I square times I square. Now substitute, so I square is negative 1. So negative 1 times negative 1 is positive 1. So now, if we need to simplify I to any power, the answer is one of these four. It is equal to I, or negative 1, or negative I, or positive 1. So let us explain. I to the power 29 is equal to I to the power 28 times I. So rewrite this 29 as a multiple of 4. So multiple of 4 is 28 times I to the power 1. So if we multiply these two, I to the power 28 times I to the power 1 equal I to the power 29. Now I to the power 29 is I4 raised to the power 7. So use the properties of exponents. So power to a power rule, we multiply the exponents. So 4 times 7 is 28. Then times I. Now I to the power 4 equal what? I to the power 4 is 1. So substitute 1 for I to the power 4. So we have 1 to the power 7 times I. 1 to the power 7 is 1 times I equal I. So now I to the power 29 is equal to I. I to the power, simplify I to the power 19. So 19, I need to rewrite 19 as a multiple of 4. So here we have 4, 8, 12, 16. So we can rewrite it like I to the power 16 times I cube. So 16 is I4 raised to the power 4 times I cube. I cube equal what? Equal negative I. Look here. I cube is negative I. So now, I to the power 4 is 1. Substitute 1 for I to the power 4. So 1 to the power 4 times negative I. So now, 1 to any power equal 1 times negative I equal negative I. So the answer here equal negative I. So I to the power 19 equal negative I. Another example. I to the power 100. So 100 here is a multiple of 4. So we can rewrite it like I to the power 4 raised to the power 25. I to the power 4 is 1. 1 raised to the power 25 is 1. So 1 times 1 times 1, 25 times is equal 1. Simplify and write in the form a plus bi. So simplify this fraction, which is a complex number. So here, look at the denominator. The denominator consists of one term, which is 2 times square root of negative 4. Now let us simplify. So 5i cube, we keep it, also 2. Now square root of negative 4, we can rewrite it like square root of 4 times negative 1. Square root of 4 equal what? Equal 2. Square root of negative 1 is I. So now simplify. So here we have I and I cube. Divide out by I. So I cube divided by I is I squared. So we get 5 I squared over 2 times 2 is 4. But I squared is negative 1. So we get negative 5 over 4, which is a real number here. But we can do it like a complex number. So we can rewrite this number as negative 5 over 4 plus 0 times I. So here the imaginary part is 0. The real part is negative 5 over 4. So now this form is like this, a plus bi. So now we wrote this expression in this form, a plus bi. So here a is negative 5 over 4 and b is 0. Another example. Negative 4 over 6i to the power 7. So here, to rationalize the denominator, we multiply by another complex number. So here I to the power 7. If we multiply by I, both numerator and denominator, so we will get I to the power 8. And we know that I to the power 8 is multiple of 4, and I to the power 4 is 1. So here we multiply both numerator and denominator by I, then simplify. So multiply numerators together, negative 4i, then denominators together. So we get 6i to the power 8. I to the power 7 times I to the power 1 is I to the power 8. Now I to the power 8 equal what? Equal I to the power 4 raised to the power 2. I to the power 4 is 1. And 1 square is 1. So now we can substitute 1 for I to the power 8, which is here 1. So we get minus 4i divided by 6 times 1. So we get minus 4i over 6. So here divide out by 2. 6 divided by 2 is 3. Negative 4 divided by 2 is negative 2. So the answer is minus 2i over 3. I need to rewrite this in the form a plus bi. So we can rewrite it like 0 minus 2 over 3i. So here the real part is 0. The imaginary part is negative 2/3. Now tell whether the complex numbers are equal. So now we know that these two complex numbers, a plus bi, the other one is c plus di. These two complex numbers are equal if and only if a equals c and b equal d. So if the real part is equal, the imaginary part is equal, so we will say that these two complex numbers are equals. So now tell whether these two complex numbers are equal or not. So the first one is square root of 4 plus square root 25i. The second one is 2 minus negative 5i. So let us simplify the first one. Square root of 4 is 2. Square root of 25 is 5. So the first complex number is 2 plus 5i. Now simplify the second one, which is 2 minus negative 5i. So 2, negative times negative is positive. So now these two complex numbers are equal because the real part is the same, so 2 equal 2. The imaginary part is also the same, 5 and 5. So since 2 equal 2 and 5 equal 5, then these two complex numbers are equal. While these two complex numbers are not equal. Example 2. So the first complex number is square root of negative 9 minus I. The second one is 4i. Let us simplify the first one. Square root of negative 9 minus I. So square root of negative 9 equal 9 times negative 1 minus I. Square root of 9 is 3. Square root of negative 1 is I. So 3i minus I equal 2i. While the second one is 4i. So now is 2i equal 4i? So the first one, we can rewrite it like 0 plus 2i. This is complex number. The second one is 0 plus 4i. So here the real part is 0. The imaginary part is 4. While this, the real part for this one is 0. The imaginary part is 2. So now the real part is equal. So 0 equals 0. But the imaginary part is not equal. So now since 2 not equal to 4, therefore these two complex numbers are not equal. So try to solve some exercises from the textbook from this section 10.7. Thank you.